Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with Green's theorem problem. See the problem, verify Green's theorem in the xy plane for integral over c 3x minus 8y square into dx plus 4y minus 6xy into dy, where c is the boundary of the region given by x is 0, y 0, x plus y equal to 1. So first of all, Green's theorem, the definition and statement of the Green's theorem is nothing but integral over c u dx plus v dy equal to double integration of the region dou v by dou x minus dou u by dou y into dx dy. So this is the statement of the Green's theorem. Verification is nothing but this is the verification. So the verification is nothing but left hand side, right hand side, the values are equal, then the Green's theorems are verified. Now what is given? X, see here, given the line, given x 0, y 0, x plus y equal to 1. So this is a line equations are given. Now integral over c, the left hand side of the Green's theorem, this is a left hand side, this is a right hand side. So the left hand side is nothing but integral over c u dx plus v dy. Now the given problem, integral over c 3x minus 8y square into dx plus 4y minus 6xy into dy. This is a given problem. Now compared to the statement of the left hand side for the given problem, because integral over c, the u value, this is a u, dx coefficient u. So this is a u value, this is a v value. Because of, let u equal to 3x minus 8y square, then v equal to 4y minus 6xy. From this equation, see left hand side and right hand side is u differentiate partially with respect to y and the v differentiate partially with respect to x. Therefore from the equation, partial derivative dou u by dou y and then dou v by dou x. When I partial derivative of this, y is only variable, other term constant. For this v, x only variable, other terms are constant. When differentiate partially with respect to y, first term 0, 8 constant 2y. So this is a minus 16y. For this one, 4y constant 0 minus 6 x differentiation 1 and then y minus 6y. Now next is right hand side. What is the right hand side? The right hand side is nothing but double integration of the region dou v by dou x minus dou u by dou y into dx dy. Now given the point, what is a given? See, given x 0, y 0, x plus y equal to 1. Now the graph, I am ready to draw the graph. To consider, this is a x and this is a y, this point 0. So when this line given x 0, this whole line to consider x 0. When y 0, the whole line y equal to 0. Then x plus y equal to 1 line equation. Before to draw this line to find the coordinate points. What is the coordinate points? See, this is to consider. Put x 0 to take any number. Now I simplification, very simple point of view, simple points I am taking. You just take it any number, x 2, 3, 4, 10, 20, whatever. But the simple 0 is very simple to find the value. When I substitute x 0, 0 plus y equal to 1, from this y equal to 1. Now the coordinate point x comma y, x value 0, y value 1. Where this point is there? See 0 here, to consider 1, this 1, 0, 1 means this is a point 0 comma 1. And then put y equal to 0. So 0, x plus 0 equal to 1. For this equation x equal to 1, the coordinate point 1 comma 0, where this point here to consider 1 comma 0. So this is a 0 comma 0. Now the line equation is nothing but this is a line. The line is from this 0 comma 1 and then 1 comma 0 to draw the line from this point to this point. Now the region, this is our region. This is a region. Now this equation is x plus y equal to 1 and this line is y equal to 1 and this line is x equal to 1. Now when I am just writing here the equation right hand side, double integration of dou v by dou x. See, we know already dou v by dou x is minus xy and then minus dou v by dou x minus xy, dou u by dou y minus 16y into dx dy. Now here dx means x region. What is the x region? Now to consider x is the function. When x is the function, now see what is the value here, x is the function. Now from the x line horizontal to from this point to this point line is x0 and this line x plus y equal to 1. From this equation x equal to 1 minus y, x equal to 1 minus y. Therefore x 0 to 1 minus y. Then y value, y is where? Here 0 to 1, y 0 to 1. When simplify y 0 to 1, x 0 to 1 minus y, for this is a minus 6y, minus of minus plus, so 16 minus 6, 10y dx dy. Now first integration with respect to x. Therefore, so 10y consider constant, y 0 to 1, 10y constant, so dx integration x 0 to 1 minus y into dy. Now substitute upper limit and lower limit, 1 minus y upper limit minus 0 lower limit into dy. Therefore now 10 is a constant I am taking out, y 0 to 1. When I multiply y inside this bracket, y minus y square into dy. Integration of y integration y square by 2, y square is y cube by 3, 0 to 1. Now 1 by 2 minus 1 by 3 upper limit, 0 minus 0 lower limit. Taking this LCM, cross multiplication, so 3 minus 2 by 6, 1 by 6, 10 by 6. When to cancel from 2, 5 by 3. So this is our right hand side value, 5 by 3. Now I am taking this picture. So now the left hand side. Now taking left hand side. What is the left hand side? Left hand side equal to integral over c 3x minus 8y square into dx and then plus 4y minus 4y minus 6xy into dy. Therefore this value, I think the graph, to consider this is a point O A B. This is our region, but the problem is the single line, but the region to cover O to A one line, A to B another line, and then B to O another line. So 3 lines to find to cover the single line region covering. So therefore this to write in terms of integral O to A to B, then B to O. The single line to split with into 3 line, 3x minus 8y square into dx plus 4y minus 6xy into dy. Now what is the first line? O to A, integral O to A. If O to A, see O to A, the value y equal to, what is the value? Y equal to 0. O to A, y equal to 0. So when y equal to 0, y equal to 0, the derivative dy equal to 0. Now into this function, this equation is substitute. Okay, then plus integral, then next A to B, the A to B is nothing but x plus y equal to 1, then x equal to 1 minus y. So what is the meaning this? A to B, x equal to 1 minus y, dx equal to minus dy, x equal to 1 minus y, then dx equal to minus dy, to consider this variable. Or if you want to change this x plus y from this x plus y to y equal to 1 minus x and dy equal to minus, whatever the form, other form, because of this line equation x plus y equal to 1. So now y equal to 1 minus x, dy equal to minus dx. We want to change all variable in terms of x, we can make it that, or change every term in terms of y also, because single line, single variable. Now substitute here the function, multiplication of the function. What is the function? See, this is the 3x minus 8y square into dx. This is the one. And what is the third line? B to O. Third line, B to O. B to O, x 0, x equal to 0, x 0, dx 0. Now this is our equation, the function. This is our function. Now substitute the value. What is the value? The first line, dy 0, y 0. When dy 0, 0 into whole term 0. When y 0, this term 0. Therefore integral 3x into dx, 3x into dx, other term 0. When 3x means O to A, x range. What is the x range from this equation? See, the first one 0, 0, 1, 0. What does it mean? x 0, x 1, 0, 1. Therefore x 0, x 1, x 0, x 1 plus integral over, then to substitute where dy to change dx, minus dx, where y to replace 1 minus x, here 1 minus x. Therefore 3x minus 8, y square is nothing but 1 minus x square, then into dx, then plus 4y to change in terms of x, so 1 minus x, minus 6x into 1 minus 1 minus x changes y in terms of x 1 minus x into dy is minus dx. This is a second line. So the range, what is the range? See, x range, because I changed every term into x. A to b x point 1 to 0, x point 1 to 0. So x equal to 1 to 0 plus integral. What is the next one? X is 0, dx is 0, x is 0, dx. So dx 0 into any term 0, then this is x is 0. Therefore 4y dy. When the y range from b to o y range 1 to 0, b to o y range 1 to 0. Therefore y equal to 1 to 0. Now to simplify this, because we have this equation, to simplify first x 0 to 1 3x dx plus x 1 to 0, when I expand this 3x minus 8 a minus b whole square, a square plus b square minus 2ab into dx. For this term plus 4 minus 4x, then minus 6x plus 6x square. When I multiply minus 6x plus 6x square into minus dx, and then plus y 1 to 0 4y dy. Now to simplify this term, integral x 0 to 1 3x dx plus integral x 1 to 0. Now to simplify dx to take common, 3x minus 8 minus 8x square plus 16x, and then minus 4, because minus this minus I am taking common out, minus 4 plus 4x plus 6x minus 6x square into dx, then plus y 1 to 0 4y dy. Then simplify the term, square term. So this square and square. So what is the value? Integral x 0 to 1 3x dx plus x 1 to 0, the minus 8x square minus 6x square minus 14x square. Then x term means 3x 16x 4x 6x, so 10 26 29x, and then minus 8 minus 4 is a minus 12 into dx plus y range 1 to 0 4y dy. Now integration. What is the integration? The first one, 3 constant, x integration x square by 2 0 to 1 plus, then this is a minus 14 constant, x square integration x cube by 3 plus 29 constant, x integration x square by 2 minus 12 into x, 1 to 0 upper limit lower limit 1 to 0, then plus 4 constant y square by 2 1 to 0. Now substitute upper limit lower limit 3, upper limit 1 square by 2 minus 0 plus this upper limit lower limit. Then when I substituted 0 upper limit, 0 plus 0 minus 0 upper limit, minus of lower limit minus 14 by 3 plus 29 by 2 minus 12. This is upper limit minus of lower limit plus 0 minus 4 by 2. Now the term is 3 by 2 plus 14 by 3. When I multiply minus into minus plus minus 29 by 2 plus 12, then minus 4 by 2. 4 by 2 is 2. Therefore, this is a 3 by 2, 14 by 3 minus 29 by 2 plus 10. 12 minus 2, 10. Now, taking this LCM, 6 I am taking LCM. If you are not familiar with the taking LCM, better use calculator to write in the decimal value. When I am taking 6 LCM, here 2. So, now to change 2 to 6 means numerator denominator multiply with 3. So, 3 means 9 plus 3 into 3 9 plus here 2 to multiply 28. For here 3 to multiply, so 29 into 3. So, 7 3 into 9 and 6 87 plus 10. Therefore, the term is nothing but 28, 38, this is a 28. So, 8, 7, 7 and 1, 2, 3, 47 minus 87 by 6. So, this is a value. Then I missed minus plus. So, the first term 3 by 2. First term 3 by 2. Then next term 14 by 3 minus 29 by 2 plus 12. Then this is a 228 3 29 into 3 87. This is a 10 12 minus 10. Sorry, this is I missed to multiply. Taking LCM 10 here, 6 to multiply 60. Sorry, this is a 60. Therefore, now to simplify this, 60, then 88 and then 9. So, 9 plus 8 is 7, 17. So, 1, 6, 8, 97 minus 87 by 6. So, 10 by 6, 5 by 3. This is the left hand side value. Now, left hand side equal to right hand side. Therefore, Green's theorem verified. So, left hand side 5 by 3, right hand side 5 by 3, then the Green's theorems are verified. Thank you.